Welcome. In this lecture in linear data analysis, we'll explore a fundamental method in our field. This method is called principal components analysis. It's also well known by its acronym PCA. To understand this, we'll explore a covariance matrix in greater detail by looking at the eigenvalues and eigenvectors of that covariance matrix. This will be closely related to the SVD of the difference matrix of our original data. And we'll explore how we can reconstruct this using these principal components from principal components analysis. As we go through this lecture, we can keep in mind the problem of what captures most of a data set, and what do we mean by most, and what do we mean by capture. Let's take an example. Let's suppose we have a fictional course and we have a limited amount of tabulated data. So here we have some names of students and how they performed on a few of the tests, and of course there are many more students missing and there are many more tests that might have been given in this course. One of our first problems is this how the data should be represented in a matrix? And we would think, well, it's not clear that we can average along a student, but we do know that we could average, for example, along tests. So this suggests that the first thing we should do is transpose this table into a matrix. What that would then give us is an easier way to manipulate our data. And the pattern that we're looking for is, suppose that we were to take this data as it is and we were to look at the mean along this test. Each student is going to vary plus or minus from that mean. And the question is, what's the main or principal way that students vary from a fictional average student? So the first thing that we have to do is sort out what is an observation and what is a variable. This is something that I have to do every time I look at a new data set. So here the variables will be the grades on the test, and those will be columns. And then the observations will be how each student has been graded on those tests, and that will be a row. So that means that we will take our original table and we'll transpose it into a matrix. We'll call that matrix A, and it has real numbers, and there are m rows for m students and n columns for n tests. So in our case, this is what the data would look like. Now, let's see how we can process this data.